So I would go to a slightly thicker pen here. Again, whenever there's some really important information, I would do it in just slightly different way to the rest of the board. Visually, it focuses the attention to that particular place. I would write down the equation for specific heat capacity. Now, when I show them this C, sometimes they'll say, well, what is that C? What does it stand for? Because it's not intuitively specific heat capacity. This can happen with lots of equations. When doing an equation like this, I might add some annotations around it just to make it a little bit more obvious as to what these things are. I would change the thickness of my pencil. I can then write that this is change in temperature. Really small detail. Because that's written in a slightly different, thinner pencil, it doesn't detract anywhere near as much from the equation, which is on what I want them to focus on long term. Once I've written this down and they've made a note of it, short-term memory deduces that they'll just remember that, and I could possibly even delete it in a couple of sessions later on. For now, I can say, well, this is the specific heat capacity, obviously is the mass, they should know that, and this is the change in energy. Writing in small print, thinner pencil, it doesn't look anywhere near as messy, it looks nice and neat. If I just do write it in the same one, this implies it's just as important as the equation. This implies that I want you to focus on this as much as this, when that's not true. And it just looks messy. A little tip that I use with myself and use across all of my boards in all of my students is to format any equations or even diagrams, annotations if you like, in this way. And I think it makes a big difference. We've got the information here, the specific heat capacity for water. So make up a mass, give me a number for a mass of water. One, there we go. What's the specific heat capacity of water?
4,186.
It is, yeah. And now we need to come up with a change in temperature. 100, right. So we're going from 20 to 100 precisely. Nice notation with the brackets there, Michael. Like that. Sometimes my students, they don't bring a calculator to the session. So I'm going to choose an app here, just a normal calculator. And you can see that, you can use that, put the numbers in and see what we get. There you go, 334,880 joules. So if we wanted to take a kilogram of water and heat it by 80 degrees, it doesn't even need to be from 20 to 100. It could be from 100 to 180 for a particular substance, not for water, because then it'd be steam. But if we wanted to raise it by 80 degrees, then that's the amount of energy that we would need to put into that. Assuming that no energy is going elsewhere, that's the temperature difference that we would achieve. Nice one, Michael. That was all done in-house using apps that are available there. ChatGPT, fantastic. Also for explanations and descriptions. You don't just want to teach the specification. A student who's engaged, particularly one that's engaged, will ask you a question about anything that's related to it. So that might be something we just take a couple of minutes out of the lesson to chuck into ChatGPT and see what it says, and it gives us then a discussion point. Although isn't going to help them on their exam explicitly, is fantastic for building rapport and engagement with a student. So a super useful tool.